Assalamualaikum warahmatullahi wabarakatuh and hi everyone. We are students from College of Computing, Informatics and Mathematics, Diploma in Statistics, CDCS 111 from class CDCS 111 3B. Today, our group will present about application of system of linear equation for subject MAT 263 Linear Algebra 1.
Assalamualaikum warahmatullahi wabarakatuh. My name is 𝗓𝗏𝗔𝗠𝗏 with matrix ID 2022662938.
Assalamualaikum and hi, my name is 𝗓𝗏𝗔𝗠𝗏 and my student ID is 2022645526.
Hi, my name is 𝗓𝗏𝗔𝗠𝗏 and my student ID is 2022479712.
What is the system of linear equation? A system of linear equation is a group consists of more than one linear equation. Therefore, linear equation can be defined as an equation where the highest power of the variable is always and only 1. Px plus q equals to 0 is the standard of a linear equation, where x is a variable, p is a coefficient, whereas q is constant. Linear equations simplify the relationship between the unknown variable and the studied information. So, what is the purpose of linear equation in real life? The linear equation can be used in real life such as dietary, medicine dosage, the speed of a moving object, money-related problem, and times. Here is an example of the system of linear equation. As you can see, the highest power of the variable is always and only 1. There are 4 methods to solve a linear equation problem, which are Cramer's rule, Ebers, Gauss-Jordan, and Gaussian elimination. So in this case study, we are going to apply the system of linear equation in real life by using Cramer's rule. Why do we choose Cramer's rule? Cramer's rule uses determinant to solve an equation. This formula is also suitable for 3x3 matrices, which is a small system of equation. And Cramer's rule also provided a direct formula for the solution.
Now, I would like to explain our case study about nutrition. The following table shows the carbohydrate, fat, and protein content of 3 food types. The weight for each food type is represented by gram per 100 grams. Let's see. For the first food type contains 13 carbohydrate, 10 fat, and 13 protein. For the second food type contains 4 carbohydrate, 4 fat, and 3 protein. For the last food types contains 1 carbohydrate, 0 fat, and 10 protein. A nutritionist must prepare a special diet using 3 food groups. The diet must contain 23 grams of carbohydrate, 80 grams of fat, and 39 grams of protein. How many grams of each food type must be used to meet the diet requirement?
We have 2 purposes of this study. The first one is to illustrate the application of system of a linear equation in order to meet the diet requirements. The second one is to conclude which food types has better required amount to meet the diet requirements.
The method we use to solve the case study is Cramer's rule. Have you guys heard about Cramer's rule before this? Let me explain what Cramer's rule is. Cramer's rule is a method for solving a system of linear equations using determinants. It's applicable when the system has the same number of equations as unknowns and the coefficient matrix of the system is square matrix. The system of linear equations must have unique solution to apply this method. First and foremost, we can let X be the unit of food type 1 in grams, let Y be the unit of food type 2 in grams, and let Z be the unit of food type 3 in grams. Step 2. Write the data from the table in form of linear equations. From the case study, it states that the diet must contain 23 grams of carbohydrate, 80 grams of fat, and 39 grams of protein. Therefore, we can form equation followed by the columns and we'll get these three equations: 30x plus 4y plus z equal to 23, then x plus 4y equal to 18, and 30x plus 3y plus 3z equal to 39. Nextly, step 3. Convert the linear equation into a metric representation form, which is A as equal to B. A represents the coefficient matrix, which is 13, 4, 1, 10, 4, 0, 13, 3, and 10. Then, the X represents the variable matrix X, Y, and Z. For B, it represents the constant matrix that we get from the case study, which is 23, 18, and 39. Step 4. Find determinant of the coefficient matrix A using cofactor expansion. The formula of cofactor expansion is determinant of A, or also called as det A, equal to AD minus BC. You can choose any row or column to find cofactor expansion, but we choose the first row and third column since it is zero value to easily find the cofactor expansion. As you can see number 1 in the red circle, we cross the value 1 by intersection, which is the first row and third column. Then, we get the number in the square shape, which is 10, 4, 13, and 3. We put value 1 and multiply with the determinant from the number in square shape. Number 2, apply the same method as number 1, but since it's zero value, whatever number multiplies with 0, you still get 0 value. Then, you can simply put 0 without the determinant. Lastly, number 3 still applies the same method as number 1 by crossing the value 10 by intersection, which is the third row and third column. Then we get the number in square shape, which is 13, 4, 10, and 4. We put value 10 and multiply with the determinant from the number in square shape. After that, use the formula of a determinant, which is AD minus BC. Besides that, the place signs alternates from positive to negative as we move across the rows and down the column, as you can see in the right bottom corner of the slide. Then, calculate the value and get 98. Step 5. Find the determinant of AS using cofactor expansion, but have to replace the first column with constant matrix, which is 23, 18, and 39. Apply the same method from step 4 and then you will get 19A. Same goes to step 6. Find determinant of AY using cofactor expansion and replace the second column with the constant matrix. Then you will get 119C. Step 7. Find the determinant of AZ using cofactor expansion and replace the third column with constant matrix. Still, apply the same method from step 4 and you will get 119C. Then, step 5. Find the values of X, Y, and Z by using formula of Cramer's rule, which is that of AI divided with that of A, where AI is the matrix obtained by replacing the ith column of A with the constant matrix, and that A is the determinant of matrix.
Result and discussion. We were able to determine how many grams of each food type must be used to meet the diet requirement. For food type 1, which is X, we got 1, food type 2, which is Y, we got 2, and lastly, food type 3, which is Z, we got 2. Therefore, the nutritionist should add 1 gram of food type 1, 2 grams of food type 2, and 2 grams of food type 3 to meet the diet requirement. Conclusion. In this case study, we have discussed how to use Cramer's rule to solve our system of linear equation that has unique solution and many unknowns. By applying this approach, we can improve our ability to to identify rows and columns as well as learn how to use cofactor expansion to obtain the determinants. In summary, we may determine which food type have the lowest required amount to satisfy diet requirements by applying Cramer's rule.